1/2 times.
2 1/3.
So that would be
7/3.
3/3, 3/3. So yeah, 7/3 plus 1/3, so 8/3, right? So this would be 7/3 here, and then plus a third is 8/3. The ones cancel here at the end, so 4/3. So not a bad one, but if you don't know average value, then it would be hard to do. So D.
Forgot for a minute I was confused as how you got 4/3.
Yeah.
Then I got it.
Proud of you. Average value, definitely something I would make sure you know well in case it shows up. Okay. Let's look at 7. Integration. You're good.
Do you have Olivia come for?
Yes.
Can I borrow her?
I'm sorry. I was on a field trip and didn't read that email. I'm sorry.
Thank you.
Yeah, you're no problem. I should have sent her down. Okay. This one, let's go ahead and integrate it. We can actually... We notice this is from negative pi over 4 to pi over 4. You could kind of use symmetry-ish. I'm just going to go ahead and integrate it like normal. What squared gives you, or sorry, the derivative of what gives you tan?
Nothing squared.
You want
Don't you change it to sine over cosine?
Oh yeah, we want to do that. Yeah. Change it to sine over cosine. That makes your life easier. Because tangent is not one that's a nice... The derivative of nothing gives you tangent. So you want to think that way first, but then you'll notice quickly that nothing, the derivative of nothing gives you tan. Now, we did have a formula for integrating tan. I don't necessarily expect you to memorize that, but this is another way that will get you the answer.
Wait.
Yes.
So normally you would have to know that formula, right? But can't you technically, like for everything else, just turn it into the form of sine and cosine, or cosine and sine?
Yeah, I would probably do this way. I don't know that formula. I don't have it memorized. I gave you one. I would just do it this way probably.
Okay.
Yes. And now when you do it this way, I'm taking the integral of a rational function. So I would do
U sub.
u sub and let u be
Cosine?
cosine x. du is negative sine x dx. This is one where you're going to need to know the unit circle decently well. We're doing u sub, so I'm going to turn my intervals in terms of u. So plug them in for x. What's cosine of negative pi over 4?
7.
I don't know, get your unit circle out. I don't have one out with me. I don't know. You have one somewhere. I don't know if I have one somewhere. I don't know where mine's at. I given all mine's
Square
out.
root of 2 over 2.
Do what?
Square root of 2 over 2.
It's the negative pi over 4.
Oh.
Negative square root of 2 over 2?
Yes. No.
No.
No, it's
Cosine is x,
Yeah,
so it's positive.
Still be square root of 2 over 2.
Square root of 2 over 2. Yes. So you're gonna need you would need unit circle for this one. So negative pi over 4 is down pi over 4, and your cosine is x, value of the ordered pair, so it's a positive. So square root of 2 over 2. Pi over 4 is also square root of 2 over 2.
Things are 0.
Yeah. Now, if I plug in u, we're gonna have u on the denominator. I have a sine x dx left, so I'm gonna have to take this over here and divide by negative 1. And then that will give me 1 du. Now technically, if you go through and integrate this, the integral of 1 over u would be ln absolute value of u, and then you'd have to plug in your interval. However, we had kind of a theorem, or just think about what integration is. Integration is the area under the curve. So if I want to know the area, and my x values are the same, What's my area when I don't give you any width?
0.
0. So it's b. So that actually worked out to use the shortcut. Whenever you have an integral of the same thing and the same thing, there's no width to it, so your area under it is 0. Eight. If I look at 8, vertical and horizontal asymptotes of the graph y equals x over e to the x. Vertical asymptotes, how do I find out vertical asymptotes? Where my denominator is 0. So e to the x, you should know the graph of e to the x. It goes through the point 0, 1. Any basic exponential function will kind of have that same pattern. So what value of x will give me 0? Nothing, because there's an asymptote here. So e to the x will never give me 0, so that means I have no vertical asymptote. So it's either a, c, or d, or sorry, a, c, or e, right? Horizontal asymptote, how do I find a horizontal asymptote?
Exponents?
Yes, except the bottom is a polynomial, so you can use the shortcut if you have a polynomial over a polynomial. The bottom is not a polynomial. So I need to find the limit as x approaches infinity. So this is why I kind of showed you both ways, because sometimes if you have to find the horizontal asymptote and it's not a polynomial over a polynomial, you can't use the shortcut, nor can you do the divide everything by the highest exponent in the denominator. That only works when you have a polynomial over a polynomial. So as I'm looking at the limit of this, let's think what we have. My top is going to go to what? So I'm going to have infinity over. If I plug in bigger and bigger numbers for e to the x, look at your e to the x graph. As I keep going to the right, is getting infinity. I end up with infinity over infinity, which is indeterminate. So then I'd have to do L'Hopital's. If I do L'Hopital's, it's not a hard L'Hopital's. The top will become a 1, which I like because when I have a fraction with a constant over something, I can kind of think about it and get an answer for that. E to the x is e to the x. So I know I'm thinking I have a constant and my bottom is getting bigger and bigger and bigger. So the whole thing is going to smaller. So it is C. So that usually with horizontal asymptotes, if it's a polynomial over a polynomial, either use a shortcut or you can do your limit and you can divide by the highest exponent in the bottom. However, since I have e to the x in the denominator, you had to do limit as x approaches infinity, infinity over infinity, indeterminate L'Hopital's, and then you could actually think about it.
Vertical asymptotes is where it's undefined, correct?
The denominator is 0. And the denominator is not 0 anywhere because of the e to the x. Okay, 9. Had something like it. So if I look at 9, if f double prime of x is sine x, f prime of 0 is 0, and f of pi over 2 is negative 1, then what is f of pi? We've had a decent amount like this. So we're going to start with our f double prime and we're going to work backwards. So from f double prime to f prime, we're going to integrate or take the antiderivative. Same thing. The antiderivative of sine x. The derivative of what gives me sine x? Negative cosine x. Because the derivative of a cosine gives me negative sine, so I need the negative to cancel it out, plus c. Before I take the derivative, I need to figure out what c is. How do I figure out what c is? Yes, it gives you the information. When I plug 0 in for x, I should get 0 back. So 0 equals negative cosine 0 plus c. Cosine 0. One. So 0 equals negative 1 plus c. Add 1. 1 equals c. So your first derivative is negative cosine x plus 1. Now to find f of x, normal function, we're going to work backwards again. Derivative of what gives me negative cosine x? Negative sine x. The derivative of sine gives me cosine, and do the negative. Plus 1x plus c. How do I figure out what c is? Plug pi over 2 in and set it equal to, so negative 1 equals negative sine pi over 2 plus pi over 2 plus c. Sine of pi over 2, so negative 1 plus pi over 2 plus c. Kind of weird with the pi over 2, that's just a number. So we're going to add 1 and subtract pi over 2 from both sides. 1's cancel, so negative pi over 2 is c. And then my original is f of x equals negative sine x plus x minus pi over 2. But pi over 2 is just a number. And then my actual question is f of pi. So f of pi will be plug in pi. So negative sine of pi plus pi minus pi over 2. Sine of pi, 0. So 0 plus pi minus pi over 2. And then pi minus pi over 2. Pi over 2. So d. So we've seen a lot like those where you have to work backwards. So whether it shows up or not, I don't know. But
Number 10 would be transport to direction.
we'll see. Let's look at 10. I looked at it at the end of. I want to get through 11 because then we're done with. We'll get through 11. We'll go down. I guess 11 is not multiple choice, but if I look at 10, this is one we talked about it a little bit yesterday. We had some on chapter 3. I forget which one exactly. Study guides and tests, where you were given the original function and you had to draw the derivative graph. So what you have to do on this one is you have to label f, f prime, and f double prime. So I'm just going to start with the top. And let's just say, okay, let's say my top is my f function. So if the top is the f function, to go from the f function to the first derivative function, first thing you do is you look at where you have a horizontal tangent line, because that is where your first derivative graph is going to touch 0 at, because that's where I would have a first derivative of 0. So if the top is the original function, where does it have a horizontal tangent line at? 0. So then I know that my first derivative graph is going to have to touch at 0. Do either of the two remaining graphs touch at 0? No. So I know the top is not the original. So now we're going to move on to the middle one. Let's say, okay, what if the middle one is f of x? It's the original. Where is the horizontal tangent line for the middle graph? 0. So then I say to myself, okay, in order to have a first derivative, since I have a horizontal tangent line, it needs to touch at 0. The top one touches at 0. We can also check, like we talked about, if I look at the original, if this is the original, I am increasing left of 0. So if I'm increasing, that means my first derivative has to be above the x-axis, because my first derivative has to be positive, because the slope of this tangent line will be positive. It is. This, on the right side, as I look at my original one, this was the original one. The derivative, the slope of this tangent line is what? Increasing. It's positive, so this will also have to be above. So that checks off. So now I go, okay, this is the first derivative. So I marked this is my original. This is my derivative. I may erase it, and I'll see if this makes sense for the second derivative. You're going to look at your first derivative, and you're going to take the derivative of that. Where is my horizontal tangent line at for the first derivative? 0. So the second derivative should go through 0. This does not. So those are not going to work. So then you go to the bottom one, and we say, okay, let's choose this to be my original. If this is my original, where is the horizontal tangent line at? Right here, wherever that's at, right here. So to find the first derivative, I know my first derivative has to be 0, -5. So my... Yes?
Okay, what is the horizontal tangent line?
Horizontal tangent line is where my first derivative is 0. So if here's where the horizontal tangent line is, that's where my first derivative will be 0. So it has to cross or be 0 at that same point.
It's where it's neither increasing or decreasing, basically.
Right.
Okay.
So if this was my original, if the bottom was the original, I have a horizontal tangent line here. It's the low point. Basically, low points are high points. That has a first derivative of 0. So the middle one would be my first derivative because that's where it's 0. The first derivative is 0 at -5 or whatever the x value is. And then I could check also, it's going down. The original is going down, negative tangent line slope. So my first derivative needs to be below or negative. Everything to the right is increasing, so it has a positive first derivative. So my first derivative has to be above. So that checks out for the first derivative. Now to find which one, see if the second one works out, you look at the first, you use the same thought process, but now we look at the first derivative and we think about taking the derivative of that. Where will I have a horizontal tangent line for the first derivative?
0.
Right here at 0. Do I have the top graph cross at 0?
Yeah.
Yes. So that marks off. Now also check increasing, decreasing. I'm increasing to the left of 0, so I'm above it. I'm increasing to the right of 0, so the derivative is above it. So this will be my second. So similar to what we did in chapter 2 where you had to switch between the first and the original. Let me see what this one looks like.
So, let's just, I'll just write it.
This isn't bad. This one won't take too long.
Yeah, this.
Okay, the graph of y equals f of x on the interval -3 to 3 is given below. To find a of x equals the integral from -2 to whatever, some x value of f of t dt. Use this to answer the following questions. I'm given a graph, so you actually aren't going to have to take the actual integration. So I'm saying find a of 0. That's saying x is 0. So if I think about it, I want to know the area from -2 to 0. So I go from -2 to 0, and I want to know the area. Let's see if they give me exactor. Did you integrate it or did you guess?
I would just integrate it if it's something like 0 2 to -2 to 0. Because you can't like make that definitive.
Yeah, we'll do this. I thought it was going to be quicker than that. Could you do
-2.
it would be hard to do. You could technically do whatever.
How does it work for -3?
You can't integrate it because you don't have a function. So you're going to have to think about pictures. So -2 to 0, here to here. So we're going to have this triangle.
Those are equal triangles. Those are rules of geometry.
This one and this one?
Yes.
What do I know both of those are, though?
It's 1, then and a half, and then like 2.5.
I know. I mean, I'll look at it. That's fine. I'll look at it. You have to guess, or you have to look at the area. But well, I mean,
-2 to 0, this box right there is 1.
yeah. There's a way. We'll look at it.
There's 1.5. But then you also have to.
What I would do, you'd find the area of this. 1/2 base times height. You could. We'll do it Monday. Okay, go and take everything with you when we go down there.
I'm not sure.
We're not coming back.
Can I just drop it off at my locker?
That's fine.
You're gonna take longer. You're longer to go the same way.
Fine.
Like other than.
Can I grab